Hello and welcome to this Silver Stripe screencast. In this episode, we're going to be talking about the ORM. So first, we're just going to go over what the ORM is and just cover the basics. Then we'll talk about dealing with individual records. And then we'll go on to dealing with aggregate data or queries to the database. Then we'll talk about something called lazy loading, which is appropriately about doing things later. And lastly, we're going to implement the ORM into our project so you can see why you would use it and how. ORM stands for Object Relational Model, and it is kind of the backbone of the Silver Stripe framework. It provides a layer of abstraction between your PHP code and the contents of the database. Anytime you're reading or manipulating records, the ORM is most likely going to be involved. So here's an easy way to conceptualize the ORM. Classes refer to tables. Instances of those classes or objects refer to records in the table. And properties on that object refer to the columns on the table. And the values of those properties refer to the values of each column. So to say that all classes refer to tables is an overgeneralization. A class must be a descendant of data object to follow this paradigm. So far, we've only been dealing with subclasses of page, which is itself a data object because page is a subclass of sitetree and sitetree is a subclass of data object. But for generic data types that don't need page functionality, you need to go further up the inheritance chain and simply subclass data object. We'll be talking a lot more about non-page database content in the next tutorial. But for now, let's imagine we have this simple data object class. It's product and it's got a couple of fields, title and price. In adherence to the ORM pattern, creating a record is as simple as creating an instance of your class. So here we have product create. Now it's important to remember that data objects don't optimistically write to the database, so if we try to pull the ID off this record, we get 0. In order to persist the record, we need to invoke the write method. For convenience, the write method returns the record's ID. Further, the create method can populate the object with initial field values. So here we're setting the title on creation. To delete a record is pretty simple. You just call delete. And to update a record, it's pretty logical. You just change the value of the property, and then you call the write method. So this should all feel very natural once you've become acquainted with it. So that's all about dealing with individual records. Now let's talk about how to query the database and get a set of records. So ORMs are essentially just APIs for writing SQL queries, right? So if you've ever worked on a project where SQL was written in line with PHP code, you probably don't have to struggle to see the value in such a tool. In general, database queries and controller view logic just don't mix. We try to avoid this as much as we can, and it becomes really redundant. Just look at how much repetition exists between these queries. Now on top of that, you need to deal with all the boilerplate of thwarting SQL injection and other foundational elements of database integration. And if you ever change database platforms, this isn't going to ship very well. Now you might say you could create helper functions to assemble queries like this, but ultimately this approach just doesn't scale well. Frameworks unanimously seem to prefer to hand off the database work to its own layer. Now, because database queries are about lists of records, not individual records, the methods we're going to use are all scoped to the class definition. As we stated before, the class is essentially a reference to a table. So this should make sense. In object-oriented programming, methods that are invoked not against an instance of a class, but rather the class itself are referred to as static methods. So let's take a look at how this works. First, let's get all of the products in the database. So you see we use the double colon. That's called the namespace resolution syntax, and we call the get method on product. Now let's say we want to get all the products that cost $100. We call this filter method, and we provide an array of all the fields we want to match to. Now let's get the top 5 most expensive products that are under $100. Now here you see the filter method takes a special syntax with this colon, and we can specify an operator that modifies the filter. In this case, it's less than, but it could be greater than, it could be starts with, ends with. There's all sorts of different modifiers you can throw at it. Sort should be pretty self-explanatory, and of course, limit. Now, as you can see, all these methods are chainable, with one important caveat. They are immutable. And that means that each one of these methods returns a new list, Once you store the list in a variable, you cannot update it after that. You can only overwrite the previous reference to it. So let's explain this a little bit further. So here we have products equals product get. If I call limit against that products reference, and now let's dump the SQL off that list, and it will not contain a limit clause. Now this is a very common mistake that people make with the ORM. If we were writing jQuery, the above approach would have applied both methods to the instance, but the ORM does not follow that pattern. It uses something called immutable data structures, and these are becoming increasingly more common in web frameworks. It means that once you create the thing, you can't modify it after that. You can only get a new copy of it. Now, just a quick note about this SQL method. You're almost never going to use that. It's only for debugging. If you can't figure out why your list isn't returning what you expect it to, sometimes you just want to dump the SQL and see what's going on. So in this case, that's what I'm doing, just to make the point. So let's update that code so that both the limit and the sort clause apply. I'll instantiate a products list by using product get and then a sort clause. And now I'll overwrite that variable by calling products limit 5. Now if I dump the SQL off that, it does contain a sort clause and a limit clause. Notice that we can either chain the methods on creation or overwrite the variable each time. Both achieve the same result. Generally, you're going to want to chain all the methods together if you already have in mind what your query is, but a lot of times the query might change based on business logic or input from the controller, so you might want to keep overwriting that variable and adding to it. So now let's talk about lazy loading, and this is appropriately titled because it's all about delaying execution and waiting until the last minute. So this is perhaps one of the strongest features of the Silverstripe ORM. Lazy loading means that a query is not executed until it absolutely has to be. This results in not only fewer queries, but also more efficient queries. So let's look at this example. If we call product get and store that in a variable, common thinking would tell us that the get method that we just invoked would execute a query similar to this. In actuality, no query is run when the method is called. Rather, Silverstripe just kind of makes a note that at some point you may be interested in getting all the products. So let's take it a step further. We'll call products equals product get, and now we'll loop through all the products and just echo out the title. Now we have run a query because the for each loop has told the ORM that we need the records and it's time to act. Up until then, the list of products was merely an idea. So what's so great about this? Well, several things. One is that we have far fewer wasted queries. For instance, if you look at these three lists I've created here, I'm calling several different methods on these lists, but only one query is actually run. When I step into this for each loop, now we're executing a query. So this provides comfort to the developer because you can sort of pass around these concepts of queries without worrying about making a call to the database until you absolutely need to. Another advantage of lazy loading is that it gives the ORM an opportunity to optimize the query just before it executes. So let's look at this. We say product get, and then we just want to get the count off that list. So rather than just returning something like a size of function on the resulting array of results, the ORM is smart enough to see that all you really want is a count, and it executes something like the following. Now obviously running the count function on the table is much more efficient than getting all the rows out of the table, storing them in memory, and maybe there's a million rows, who knows, and trying to count that array. So the ORM has stepped in here and optimized that query. So typically in Silverstripe, it's a loop block on your template, if not a for each in your controller, that actually tells the query to run. All right, so let's start implementing the ORM into our project. We're going to add a custom database query to a controller. Looking at the home page, we see there's a section where the latest articles are syndicated. To get these to display, we need to write a method in our controller to fetch the list. Let's call it latest articles. Now because this method will be used on the template, we're using the naming convention in upper camel case. Now there's no need to pass this method into the template. Because it's in the controller and is defined as public visibility, we can access it using $latest articles on the template. So let's update homepage.ss to loop through all the articles. So I'm just going to step into a loop with $latest articles as we define in the controller. And now I'm just going to go through like we've done before and start replacing these static links and pieces of text with dynamic properties like $link And we have a $ photo. Get that date format in there. The title. And of course we have the teaser, which can fall back on the first sentence of the content. We'll close off the loop and delete all of the static content below it. And we refresh the page and we do see that it is now displaying the actual articles that are coming out of the database. So we've just syndicated content to the home page. It's a really cool thing, something you're going to do a lot of. Now there's one minor improvement we can make to this function. Right now the limit of 3 records is hard-coded into the controller, which isn't very configurable. The reason we're limiting the result set is due to the constraints imposed by the layout, so it makes more sense to assign this value on the template. That way, if somewhere down the track we have 4 displaying or 5, it's clear to the designer where to make that update, and no one has to get their hands into PHP code. So let's update the latest articles function to accept a count parameter, and we'll set the default value to 3. And we'll pass this parameter to the limit method. And now on the template, we'll simply use loop latest articles with a 3 passed as the parameter. We'll go back and just check everything's working, and it seems to be. Okay, that's it for this lesson on the ORM. Thank you for tuning in. If you have any questions or comments, please leave them below.